And almost every image we're taking now, we see galaxies everywhere.
The detail, the clarity, the color, it all just hit me all at once that, yeah, Webb is a next generation observatory. It's gonna, change astronomy forever.
The James Webb Telescope just sent a terrifying message, and the results processed by scientists have left all officials at NASA in abrupt silence. The largest optical telescope in space has spent years observing multiple components of our final frontier, and several phenomena have been discovered, all thanks to the JWST. However, this recent image it sent has turned out to be the biggest shock in the world of science and astronomy. What terrifying image did the James Webb Telescope send? Could it have photographed an alien spaceship on the edge of space? Join us as we explore how the James Webb Space Telescope just sent terrifying new images that we weren't shown. The National Aeronautic and Space Administration's $10 billion James Webb Space Telescope was launched from Europe's spaceport in French Guiana, and after it arrived at its new cosmic home, the Infrared Observatory has provided scientists and astronomers with some truly breathtaking views of the cosmos. As the largest and most powerful space telescope to date, scientists were thrilled to see the first scientific images of the telescope, but what they saw almost petrified them. When JWST turned its instruments to the iconic pillars of creation, the observatory grasped the famous dust clouds in incredible detail. Found in the constellation Serpens, approximately 7,000 light-years from Earth, the pillars of creation are part of the Eagle Nebula. The large clouds of gas and dust were initially photographed by the Hubble Space Telescope in 1995, and it was the pillars of creation's remarkable beauty that brought them to light from then on. The new photograph taken by JWST showed the pillars in even more detail. Several stars which were not seen in the previous image taken by Hubble are seen shining in the image, and some were born just a few 100,000 years ago. Well, that's one scientific breakthrough, but come to think of it, what if these are landmarks built by aliens? James Webb Space Telescope opens Pandora's cluster in a stunning image with help from Einstein. In Greek mythology, Pandora's inquisitiveness caused her to open a container that held all of the evils and hardships. As soon as Pandora opened it, they escaped and are still roaming around in our world today. Now it looks like the James Webb Telescope has done something similar, but there were no evils released. The JWST only zoomed in on a particular area of space named Pandora's cluster, using a case foretold by Albert Einstein in 1915. This new JWST image left the mouths of scientists ajar as it showed details they never knew existed in the region. This area in space has a name though, and it's formally known as Able 2744. It is part of Pandora's cluster that arises from the observation of an assortment of different structures within it. One fascinating thing about this image is that it has been observed earlier, but only the central core of this region of space was studied by the Hubble Space Telescope. This means that there are a lot of meaningful secrets left undiscovered until the JWST turned its powerful infrared instruments to the area for observations. The JWST team observed Pandora's cluster with the large telescope's near-infrared spectrograph and near-infrared camera instruments as part of the ultra-deep near-spec and near-cam observations for the Epoch of Reionization program. The deep field image that came from this takes 4 JWST snapshots and stitches them together. This resulted in one panoramic image that featured a stunning 50,000 sources of infrared light. The panoramic image turned out to be a deep field image of Pandora's cluster, situated about 3.5 billion light-years away. The image taken by the JWST achieved an impressive balance of depth and breadth that could change our perception of galactic evolution. Another notable feature in the image is a bright foreground star from the Milky Way with unique diffraction spikes made by the James Webb Telescope. Within this are bright sources of white light that are surrounded by a hazy glow. These are the much more distant galaxies of Pandora's cluster. Now, although human-created technology is crucial to the observation of this cluster of clusters, astronomers also relied on a natural phenomenon that was proposed initially by Albert Einstein in his 1915 opus, the theory of gravity known as general relativity. Mysterious rings in new James Webb Space Telescope image. Apart from making mouth-watering discoveries that fascinate scientists and astronomers, the James Webb Telescope has also captured strange phenomena in space that even scientists cannot explain. One such strange capture is the mysterious concentric rings found around a distant star that astronomers still can't understand completely. The image was released on Twitter by a citizen scientist named Judy Schmidt. The moment the Twitter community saw the image, it barreled into a torrent of comments and head-scratching. The image posted on Twitter featured a star known as WR140, which was seen surrounded by regular ripple-like circles that gradually faded away. One thing in the image caught major attention, however. The circles are not perfectly round, but they had a somewhat square-like feel to them. This instantly sparked theories about likely alien origins. I think it's just nature doing something that is simple, but when we look at it from only one viewpoint, it seems impossible at first to understand that it is a natural phenomenon, Schmidt said in an email. Why is it shaped the way it is? Why is it so regular? And Schmidt was not the only scientist bothered about this image. Mark Makorian, an interdisciplinary scientist at the JWST Science Working Group and a science advisor to the European Space Agency, termed the feature bonkers in a Twitter thread. The six-pointed blue structure is an artifact due to optical diffraction from the bright star WR140 in this JWST mirror image, he wrote. But red, curvy yet boxy stuff is real, a series of shells around WR140, actually in space around a star. Well, NASA should have something to say about it, though hopefully they talk soon. Young stars in general shine bright blue. With age, stars develop a redder glow as they burn through their fuel and cool down. In ancient galaxies that Webb was built to spot, astronomers had not expected to see old red stars. They also had not expected to find galaxies more massive than perhaps 1 billion suns. But those reddish dots revealed in Webb's deep fields appear 50 times more massive than that, Leia said. The most massive galaxies now assembled are estimated to have masses 2 to 4 times lower than that of our own Milky Way, Leia wrote. This was astounding. We're finding galaxy candidates as massive as our own galaxy when the universe was 3% of its current age. Leia noted that before astronomers start rewriting cosmology theories to explain how these galaxies came together so quickly after the Big Bang, they will have to ensure the odd red dots they are looking at are not something else. Most of the alternative explanations, however, also require entirely new concepts, Leia said. For example, stars in the early universe might emit light in exotic ways due to their lack of heavy elements, and perhaps we're not incorporating those in our models, Leia wrote. Or alternatively, perhaps our understanding of how stars form locally, for example, how many stars form from gas as a function of the mass of the stars, is totally inapplicable in the early universe. These things would also be exciting to discover and would also overturn our understanding of star formation in the early universe, just in a very different way. The images that revealed these puzzling galaxies were obtained by Webb's near-infrared camera as part of the Cosmic Evolution Early Release Science program. Astronomers plan soon to turn Webb's mirror to these galaxies again to this time obtain light spectra of those distant dots. Spectra break down the observed light according to its wavelength composition and thus reveal the chemical and physical properties of its source. The most important thing is that spectra give very precise distances to these objects, said Leia. The distance and the identity of these objects are correlated. If we know the distance, we can pin down the identity and vice versa. So a spectrum will pretty immediately tell us if our hypotheses are correct. Only a little more than 6 months after the Webb team released the first observations from the Grand Observatory, scientists are already challenged to rewrite their theories about the early universe. We looked into the very early universe for the first time and had no idea what we were going to find, Leia said in a statement. It turns out we found something so unexpected it actually creates problems for science. It calls the whole picture of early galaxy formation into question. James Webb Space Telescope's stunning phantom galaxy picture looks like a wormhole. A fresh image based on brand new deep space data appears to show a wormhole spinning before our very eyes. The appropriately named phantom galaxy glows eerily in a new image by Judy Schmidt based on James Webb Space Telescope data obtained almost 1 million miles away from our planet using the observatory's mid-infrared instrument. The image highlights the dust lanes in the galaxy, which are more properly known as NGC 628 or Messier 74. Dubbed the perfect spiral by some astronomers because the galaxy is so symmetrical, the Phantom Galaxy is scientifically interesting because of the intermediate mass black hole scientists believe is embedded at its heart. The galaxy has been imaged professionally many times before, including by space observatories such as the Hubble Space Telescope and the Wide Field Infrared Survey Explorer. However, what makes Webb's imagery stand apart from these past efforts is the mid-infrared range that highlights cosmic dust, along with the power of its unique 18-segment hexagonal mirror and deep space location. Webb observed M74 earlier this week. The data was also shared on Twitter by Gabriel Brammer, an astronomer at the Cosmic Dawn Center in the Niels Bohr Institute at the University of Denmark. James Webb Space Telescope discovers enormous distant galaxies that should not exist. Galaxies nearly as massive as the Milky Way and full of mature red stars seem to be dispersed in deep-field images obtained by the James Webb Space Telescope during its early observation campaign, and they gave astronomers a headache. These galaxies, described in a new study based on Webb's first data release, are so far away that they appear only as tiny reddish dots to the powerful telescope. By analyzing the light emitted by these galaxies, astronomers established that they were viewing them in our universe's infancy, only 500 to 700 million years after the Big Bang. Now, such early galaxies are not in themselves surprising. Astronomers expected that the first star clusters sprung up shortly after the universe moved out of the so-called Dark Ages. The first 400 million years of existence were when only a thick fog of hydrogen atoms permeated space. But the galaxies found in the Webb images appear shockingly big, and the stars in them were too old. The new findings are in conflict with existing ideas of how the universe looked and evolved in its early years, and they also don't match earlier observations made by Webb's less powerful predecessor, the Hubble Space Telescope. We had specific expectations for the type of galaxies that live in the early universe. They are young and small. Joe Ley, assistant professor of astronomy and astrophysics at Penn State and one of the authors of the study, said in an email, "Previous studies of the early universe with Hubble and other instruments tend to find small blue baby galaxies at early times, objects which have just recently formed out of the primordial cosmic soup and are themselves building their early stars and structures." Fiery James Webb Space Telescope image shows the early days of star formation. Another image taken by the JWST is a fiery cosmic hourglass that kept a fledgling star or protostar at its heart. The blazing scene is being concealed from telescopes by a dark, dense cloud of gas and dust known as L1527, and it's only visible in infrared light. The fact that this formation was only visible in infrared light made it an awesome target for the near-infrared camera on the James Webb Space Telescope to observe. When it did, it showed the formation within the Taurus star-forming region in all its glory. Astronomers are puzzled about this discovery, but they use the opportunity to make more research. They hope that checking the cosmic hourglass will provide insights into the processes happening around the protostar, which is hidden from view at the formation's neck. The observations could also give info on how infant stars attain adulthood, according to a statement from the Space Telescope Science Institute in Maryland, which operates the telescope. So this is a win for the science community, all thanks to the JWST. James Webb Space Telescope captures stunning images of Neptune's rings and moons. Sometimes the images given to scientists by earlier telescopes do not show as much information as the JWST. This recent image it took gave scientists their best view of Neptune's icy rings for 32 years since the Voyager 2 spacecraft flew past it on its way out of the solar system. It has been 3 decades since we last saw those faint, dusty bands, and this is the first time we've seen them in the infrared. Heidi Hamel, a planetary scientist at the Association of Universities for Research in Astronomy, said in a statement. And scientists were further amazed at the image because in addition to the previously known bright, narrow Neptunian rings, the JWST showed more rings. The image showed some fainter dust rings around Neptune that even Voyager 2's close-up visit to the planet in 1989 did not reveal. These are rings that scientists have never seen before. The only thing that seemed to be missing from the image of Neptune taken by the JWST is the characteristic blue color that has come to be associated with the ice giant from photos taken by the Hubble Space Telescope. However, there is a reason why it was not shown. This blue color, which appears due to methane present in Neptune's atmosphere, didn't show because JWST observed Neptune in near-infrared light. Because methane in the planet's icy clouds absorbs light strongly at these wavelengths, the planet looks somewhat dark to the JWST in areas not covered by bright, high-altitude clouds. Another important feature seen in the image captured by the JWST is a series of bright patches in Neptune's southern hemisphere. These show high-altitude ice clouds in the ice giant's atmosphere reflect sunlight before the methane in the clouds mops it up. JWST's image also showed a progressive band of high-latitude clouds surrounding a previously known vortex located in Neptune's southern pole. A thin and faint line of brightness can also be seen circling the planet's equator, which may show the global circulation of Neptune's atmosphere driving winds and storms across the ice giant. The image also shows something surprising at Neptune's northern pole. At this point in Neptune's 164 Earth-years-long orbit around the Sun, its northern pole is just out of view from the JWST's position, almost 1.5 million kilometers from Earth. Still, the most powerful space telescope was able to sight an intriguing brightness in the region of Neptune's North Pole, and images taken by the James Webb Telescope also showed scientists a look at 7 of Neptune's moons. Especially just above the ice giant in the zoomed-out version of its view of Neptune is a bright point of light that represents the moon Triton. This Neptunian moon is covered with a frozen layer of condensed nitrogen. This makes it appear so bright to the point that it outshined the methane-darkened Neptune because it reflects around 70% of the sunlight that falls on it. At a distance from the Sun that is 30 times the distance between Earth and our star, Neptune may look far. However, this is a cosmic stone's throw when compared to the stars and galaxies billions of light-years away that the JWST has been built to observe. The Neptune image further shows that although the JWST was invented to observe far-off cosmic objects, it is still giving relevant and groundbreaking results from inside the solar system. James Webb Space Telescope snaps a mind-boggling image of the Tarantula Nebula. The James Webb Space Telescope also delivered a mind-blowing and unusual view of a star-forming region known as the Tarantula Nebula. A combination of the James Webb Space Telescope's high-resolution infrared instruments displayed thousands of young stars in the stellar nursery, formerly named 30 Doradus. These are stars that have never been seen before, and scientists were further amazed at the JWST's efficiency. The incredible new detail picked up by the $10 billion Space Telescope also included gas and dust in the nebula, as well as far-off background galaxies. This amazing new detail showed that Doradus 30, initially called Tarantula for its spider-like appearance, can now be seen to also resemble a burrowing tarantula's lair lined with silk. The Tarantula Nebula is situated 161,000 light-years away in the Large Magellanic Cloud and is the brightest star-forming area in the galaxies closest to our Milky Way, also known as the Local Group. The nebula is of particular interest to astronomers who are intrigued about how stars form. The nebula has a related type of chemical conformation as star-forming regions from when the cosmos was only a few billion years old. As a result, it offered a peculiar insight into how stars were created in the deep cosmic past. James Webb Space Telescope view of Saturn's weirdest moon, Titan. Titan is a strange world, a little bit Earth-like. If the land were made of water ice, rivers and seas were filled with liquid methane, and other hydrocarbons, and the atmosphere was thick and hazy, dotted with methane clouds. And the James Webb Space Telescope observed 2 of these clouds, and the results shocked scientists. Heidi Hamel, a planetary scientist at the Association of Universities for Research in Astronomy and a project lead for JWST's solar system work, expressed his admiration for the glimpses of bright and dark regions of Titan's surface. Connor Nixon, an astronomer at NASA's Goddard Space Flight Center in Maryland, arranged for JWST to spend a total of 15 hours of its first year studying Titan. In particular, Nixon's team wanted to study Titan's atmosphere, aiming to map the distribution of the haze and identify new gases among other goals. And the scientists were thrilled at the data JWST sent them. At first glance, it is simply extraordinary. Sebastian Rodriguez, an astronomer at the University Paris City and colleague on the research, wrote in the statement, "I think we're seeing a cloud." As they pored over the data, the researchers identified not one but two clouds, including intriguingly one located over Kraken Mare, the largest of Titan's seas. The scientists were soon inspired to find a way to check back in on those clouds to understand how they changed over time. The team reached out to the Keck Observatory in Hawaii, which was able to snag observations of Titan just 2 days after. We were concerned that the clouds would be gone when we looked at Titan 2 days later with Keck. M.K. DePata, an astronomer at the University of California, Berkeley, who leads Keck's observations of Titan, said in a statement, "But to our delight, there were clouds at the same positions looking like they had changed in shape." However, that alignment doesn't necessarily mean Keck saw the same clouds as JWST. Scientists expected high cloud activity because Titan's northern hemisphere is experiencing late summer and catching more solar radiation, so Keck's clouds may have been freshly formed. However, the scientists aren't done mining the observations. They identified the clouds in images taken by JWST's near-infrared camera, which in the case of Titan allows scientists to separate out the lower atmosphere. But the researchers haven't even finished evaluating all of NIRCam's data, and a second instrument was also at work. The observatory's near-infrared spectrograph also gathered spectra. This technique splits light reflected off, for example, Titan's atmosphere and measures how much of each wavelength of light is present. These spectra should help scientists map what compounds are present in the lower atmosphere, including a strange bright spot over the moon's south pole. JWST is also scheduled to return its sharp gaze to Titan in May or June of 2023, according to the statement. This time using its mid-infrared instrument, which will refine scientists' understanding of the chemicals in the moon's strange hazy atmosphere. Observations of Titan are particularly important now in a lull between spacecraft visitors to the icy moon. NASA's Cassini mission arrived at Saturn in 2004 and flew past the moon more than 100 times before the spacecraft's demise in 2017. NASA is working on a new mission called Dragonfly, which is dedicated to Titan and will see a drone flying through the hazy skies, allowing scientists to study the moon from some 24 vantage points. James Webb Space Telescope peers into a lonely dwarf galaxy. Apart from making nearby discoveries, the most powerful space telescope also zoomed in on a lonely dwarf galaxy in our galactic neighborhood, imaging it in stunning detail. At around 3 million light-years from Earth, the dwarf galaxy named Wolf Landmark Malott for 3 astronomers instrumental in its discovery is close enough that the James Webb Space Telescope can distinguish individual stars while still being able to study large numbers of stars simultaneously. The dwarf galaxy in the constellation of Cetus is one of the most remote members of the local galaxy group that contains our galaxy, the Milky Way. Its isolated nature and lack of interactions with other galaxies, including the Milky Way, make WLM useful in the study of how stars evolve in smaller galaxies. We think WLM hasn't interacted with other systems, which makes it really nice for testing our theories of galaxy formation and evolution. Kristen McQuinn, an astronomer at Rutgers University in New Jersey and lead scientist on the research project, said in a statement from the Space Telescope Science Institute in Maryland, which operates the observatory. Many of the other nearby galaxies are intertwined and entangled with the Milky Way, which makes them harder to study. And McQuinn pointed out a second reason WLM is an intriguing target. Its gas is very similar to that of galaxies in the early universe, without any elements heavier than hydrogen and helium. But whereas the gas of those early galaxies never contained heavier elements, the gas in WLM has lost its share of these elements to a phenomenon called galactic winds. These winds stem from supernovas or exploding stars. Because WLM has so little mass, these winds can push material out of the dwarf galaxy. In this image of WLM, McQuinn describes seeing an array of individual stars at different points in their evolution, with a variety of colors, sizes, temperatures, and ages. The image also shows clouds of molecular gas and dust called nebulas, which contain the raw material for star formation within WLM. And in background galaxies, JWST can spot fascinating features like massive tidal tails, which are structures made of stars, dust, and gas created by gravitational interactions between galaxies. JWST's main goal in studying WLM is to reconstruct the dwarf galaxy's history of starbirth. Low-mass stars can live for billions of years, which means that some of the stars that we see in WLM today formed in the early universe, McQuinn said. By determining the properties of these low-mass stars like their ages, we can gain insight into what was happening in the very distant past. The work complements the study of galaxies in the early universe that JWST is already facilitating, and it also allows the telescope's operators to check the calibration of the NIRCam instrument that captured the sparkling image. That's possible because both the Hubble Space Telescope and the now retired Spitzer Space Telescope have studied the dwarf galaxy before, and scientists can compare the images. We're using WLM as a sort of standard for comparison to help us make sure we understand the JWST observations, McQuinn said. We want to make sure we're measuring the star's brightness really accurately and precisely. We also want to make sure that we understand our stellar evolution models in the near-infrared. McQuinn's team is currently developing a software tool that everyone will be able to use that can measure the brightness of all the individually resolved stars in the NIRCam images. This is a bedrock tool for astronomers around the world, she said. If you want to do anything with resolved stars that are crowded together in the sky, you need a tool like this. The James Webb Telescope has blown our minds away with these images, and scientists believe that there's a lot more to be discovered in the final frontier with this telescope. Which of these images grabbed your attention the most? Let us know your thoughts in the comments section below.